In this video, we'll talk about models containing dummy variables that can be very useful for evaluating some sort of policy or doing policy analysis or evaluating the effect of programs. So the example that we'll take is based on a study where they were interested in looking at the effects of job training, whether firms participate. So there are some firms, some participate in the training and some don't. And looking at the effect of training on earnings in the next year. So this was just a job training experiment, and JTrain 98 is the data set that we're working with. Now, the training status of a firm was randomly assigned during this should be 1996, right? 1 year before they saw the effect on earnings. So the outcome of interest is earnings in 1998, which are labor market earnings in thousands of dollars in 1998, which is the year that's following the job training program. Okay, so in this case, remember that train is going to be our binary policy variable. So we want to evaluate the effect of that policy because people were randomly assigned for this program. So let's take a look here and explore the data a little bit. So assuming that you've loaded the data successfully from the Woolrich package, we can take a look at the structure of the data. So notice here that train, which is our policy variable, which we're going to be using as an explanatory variable, is taking values that are 0 or 1. And then there are many other variables that can perhaps many other variables that can also influence the variable that we are interested in. And the variable that we are interested in is earnings in 1998. And this is a numeric variable or quantitative variable, okay, measured in thousands of dollars. So here we can explore the data a little bit further. So we can actually look at the mean of this variable train and the mean of our earnings. So this is basically telling us that about 33.2% of the firms in the sample were actually participating in the training program, and that the mean earnings were about 9.9 thousand in our data. Okay, so whenever you're trying to do program evaluation or policy analysis, it's important to see whether your policy variable or your participation in that program was randomly assigned or not, and also control for other factors. And we'll talk about, the problem when the program participation is not randomly assigned, which is the problem of self-selection in a little bit. But here we're basically regressing. We're creating a model. This should call it whatever, regression equals whatever, but we're basically regressing earnings on train, whether the firm participated in the training or not, the earnings in the previous year. So maybe because there were lower earnings in the previous year, that is the reason why such a program was even thought of or implemented. Education, age, whether you're married or not, race variables and things like that, right? So you have different variables, and then we look at the summary here. Okay, so here we can see that there is a positive effect that training has on earnings, and basically this is statistically significant. So this is basically saying that the training program is estimated to increase earnings by $2,351 on average, keeping everything else fixed. Okay, So this is important to note, right, that participation in the program actually worked to increase earnings. You can also try to look at other effects of the training program. So you might be interested in what's going on with, let's say, unemployment in 1998, right? So hoping that, you know, some training program is going to reduce unemployment. So you can also replace earnings by earn 98 by unemployment in 1998 and evaluate what is the effect of the policy. Now, there can be situations where the participation, or where the program participation is not random. And this can create some problems for us because, you know, if the problem of participation decisions differ systematically by some sort of unit characteristics, so individual characteristics or firm characteristics, then we end up into this problem of self-selection, or we end up with this problem of self-selection. Self-selection. And where self is, you know, is a broader term that's encompassing the individual or any unit that you're talking about. So in this example, for example, you know, if we're thinking about training, it could be the case that if the training for different firms is not assigned randomly, then some firms that are just happen to be more proactive and have, because they have less productive workers, were more likely to apply for such a program and get in. So, you know, other factors need to be controlled for, whether, you know, let's say here we already have it, like earnings in previous years or unemployment in previous years can actually, or whether, you know, the firm is very unproductive in previous years can govern why they even enter the program in the first place. So basically the idea is that other explanatory factors can affect whether you participate in a program or not, right? If you apply for a scholarship, let's say, to some program that could depend on your on your parental education or your family background, because your parents knew about a particular scholarship, that's why you applied for it. It was not so random, right, that these scholarships were given out, stuff like that. So you want to always try to control for other explanatory factors that can affect this the program participation, so you can isolate the effect of program participation.